Let's start off section 2.1 by just covering position real quick. And if you say the position of an object, you're just going to be referencing its location compared to an origin or to a reference point. So I sketched out a little bit of a map here with a north, south, a west, and an east, but I also put a coordinate system on top of them. So I have an x-axis and a y-axis just like you would have on a graph. And I've defined plus x to be to the right, plus y to be up, and I've decided that my house would be represented at the origin right here. And then so you could reference the position of the gas station compared to your house. And so compared to my house, compared to my origin, the gas station would be 4,000 meters to the east and 5,000 meters to the north, which would bring us here. So one way you could say it is just by using words. And then you could also state the position of the gas station as coordinates, as in it was positive 4,000 meters for the x coordinate, which means positive 4,000 was this way towards the plus x. And the y coordinate from the origin was plus 5,000 meters. So up 5,000 meters, not down 5,000, to describe where the gas station is. Now, in this example, the gas station is not moving compared to the house. So it's just going to have a certain position. It's not going to change. But if the object was in motion, like a car, then its position would constantly be changing. Which brings us to the next section, speed and velocity. All right, now speed and velocity are going to be two different things when you're in physics class. An example of speed would be 55 miles per hour. And an example of velocity would be 55 miles per hour northward. It's that direction there that makes it a velocity. So to me, speed and velocity are kind of like apples and oranges. On the one hand, they're both fruit, like they're both describing your rate of motion, but they're both different. Speed doesn't have a direction, but your velocity does tell you a direction. So be careful. If a homework question or a test question were to ask what's an object's velocity, you're supposed to give a direction. So speed doesn't have a direction, and so we would call that type of quantity a scalar. Some other scalars are time and mass and density. Like it wouldn't make sense to say that the time is 3 o'clock northwards and my mass isn't 72 kilograms to the south. They don't have directions. It doesn't make sense. And then there are other types of quantities that do have directions, and you could represent them as an arrow. And a fancy word for arrow is vector. Here's a quick example that I drew. Again, I drew an origin. Maybe that's my house again, and I drew some axes on there. But just imagine that you're looking at a map. North is up on the map, and then I drew two cars on here, A and B, and I drew A moving to the right with a velocity of 25 meters per second to the east. Now this arrow would indicate my direction, but I also wrote the direction on there myself. I'm like, if you had said 25 meters per second to the right, I'm fine with that. If you had said 25 meters per second in the positive x direction, I am also fine with that. Car B here is moving slower to the left, so 10 meters per second. And so that's why I drew a shorter arrow here. A shorter arrow is going to represent less speed in a certain direction. So I labeled it 10 meters per second west. You could have also said 10 meters per second to the left, or 10 meters per second in the negative x direction. So we introduced speed and velocity, but now let's introduce average speed and average velocity. So if you imagine taking a road trip, and you start out at a certain time and you drive maybe 3 hours, but you don't always go the exact same speed. Sometimes you have to go a little bit slower, sometimes you have to go a little bit faster, but overall you could figure out your average speed. It wouldn't be too hard. You would have to figure out your total distance traveled and then divide it by the total time taken. So like how long was your trip? So then this would be some distance in meters or miles or kilometers. And this would be some time in maybe seconds or hours. And whatever units you plug in here, you're going to get out over here. So if I plug in meters and seconds, I'm going to get out meters per second. If I plug in miles and hours, I'm going to get a speed in miles per hour. All right, now you can imagine that this would be a bit of a pain to rewrite 50 times or 100 times, so we abbreviate it. So our abbreviation for speed is V. And that was your book's choice. I don't really agree with it, but we're going to just follow what your book does, so that way I'm consistent with your book. So V is going to stand for speed, and this little bar over the top of it means average. So this represents your average speed right here. D represents the total distance traveled, usually in meters, but it doesn't have to be. Meters is SI. And T is the total time taken, which if you're doing SI, you'd plug in seconds. As a quick example, I made up this problem. Your GPS indicates that you drove for 32 minutes at an average speed of 22 meters per second. How far did you drive? So here a time was given, and also an average speed was given. So this is representing a T, and this is representing a V with a bar over it. So we have T, and we have V bar. Solve for D. So first what I did was I just wrote down that equation that I had. V bar is equal to D over T. I like the abbreviated version once I got used to it. It might take you a little while to get used to it. That's okay. And then to solve for D, what I did was multiply both sides by T, right there. And that means that these will cancel out. So that means I have distance is equal to T times V bar over here. So then basically what I just did was try to get D all by itself. So I just rewrote it over here. Distance is equal to time times the average speed. I quick converted to seconds. So 32 minutes is what I started with. Multiply by a conversion factor, where 1 minute is equal to 60 seconds. Minutes will cancel out top to bottom, is equal to 1,920 seconds. Plugged that in for T. Plugged in the average speed that they gave us. There's a seconds in the numerator here, and there's the seconds in the denominator here. And these two numbers are multiplied together. So something in the numerator over here can cancel out with that thing in the denominator over there. So then the only units that I have left are meters. Multiply the numbers, units of meters. I started off with only 2 sig figs. So I'm not going to keep this whole number, which looks like it's accurate to 4 sig figs right now. So I'm going to round it to 2 sig figs. So I'm going to have 42,000 meters. And the 2 did not round up to a 3, because that number right there was less than 5. So you could say 42,000 meters, or you could say 42 kilometers. They're both true, so I'm fine with it. This one is SI. All right, so we had speed and velocity, and they were similar but different. And kind of the same way we're going to introduce displacement now. Displacement is similar to the distance traveled, but it's different. So let's say I started from A, and I went to B. And the way to get from A to B was actually a curvy path. And the distance I traveled was 9,500 meters. So if I was finding the average speed, I would plug that in. That is the distance I traveled. And the total distance traveled is considered to be a scalar. You don't have to give it a direction in order for it to be correct. The displacement is a bit different. So to find the displacement, what you really just want to do is draw an arrow from your starting point to your final point. Just kind of as the crow flies, just straight from A to B. Your displacement is going to be that arrow, the length of that arrow, and the direction of that arrow. Because it is a vector, displacement has to have a direction in order to be correct. So in this case, I made up a value of 5,500 meters east. Why do we do that? Because that's how the average velocity is defined. The average velocity is defined as your total displacement, so that's this red arrow right here, divided by the time taken. Let's quick actually calculate the average velocity for this, and let's pretend that this took 100 seconds to go from A to B. So then your average velocity would be equal to your total displacement, so 5,500 meters east. And I'm just going to put east over here in parentheses for a second, divided by the time taken, and I had picked a value of 100 seconds. So then we would end up with 55 meters per second. Just kind of like how you had the units come down, the meters per second were kept and you rewrite them. Do the same thing with the direction. Just bring it down. There is an abbreviation for this equation. Your textbook doesn't introduce it, and I think we should just skip it for now to keep your life simpler. And just to reiterate for a second, we introduced the idea of speed and velocity, and then we talked about average speed and average velocity. You can say at a certain instant, your car has a certain speed. Like at a certain instant, you read your speedometer and you were going 47 miles per hour. That is your car speed at that instant. And you could call that your speed. I'm fine with that. Or you could call it your instantaneous speed. Just your speed at that instant. And you can do the same thing with your velocity as well. At a certain instant, I was going 47 miles per hour north.